Okay, good evening. Today we're going to be discussing how scientists solve problems. And the reality of the situation is they solve problems just like most people do, but they write it down and they make notes of everything that they did so that somebody can repeat what they do if they wanted to try and do the same experiment to either prove them correct or prove them wrong. One of the first things that you need to do before you solve a problem is identify the problem. So scientists approach this in a very orderly manner. They first identify a problem, okay? So we're just going to write this down. And write this down in your notebook so you can have it in case there's a question tomorrow on the Do Now. You're allowed to use your notebooks to answer Do Now. Sometimes they'll be collected as quizzes. So remember that and write this stuff down and bring it in, okay? All right, so the first thing that scientists do is they identify the problem and they restate that problem in the form of a question. So what scientists do is they investigate questions that they create. Okay? Once they have the question, they research the answers. And they create what we call a hypothesis. And some people call a hypothesis an educated guess. I don't really like that explanation because it's not necessarily a guess, but it's really an answer to the question that has been posed. Okay? And then once you have your hypothesis, scientists develop an experiment. That tests the answer. Okay? So we have the problem, the hypothesis, the experiment. So an experiment may be a controlled experiment. Okay, and we'll get into that in another lecture, more in detail. But just something to think about is a controlled experiment is where all things are constant. And you're going to see that word throughout this year, and constant means the same. So all things in a controlled experiment are constant, the same, except one. And that one thing is what we call a variable. Okay? So you're going to see that word over and over throughout the year too. So you might want to make note of that the one thing that changes in a controlled experiment is called the variable. Okay? After you develop an experiment to test the hypothesis, you're going to make and record observations throughout your experiment. So you're going to make and record observations throughout your experiment. You're going to record the data. So what you observe. Okay, there's two types of data that we're going to observe throughout this year. Okay, there's qualitative data and quantitative data. Okay, now the main difference, and you can see it in the words, is quality versus quantity. Okay, qualitative data refers to data that you can observe with your eyes, like how something looks. It's shiny, or it's fast. A very general observation. It's slow. It's slimy. It smells weird, or whatever. Those are all qualities of the object. Quantities have to be specific. Okay, so if something's fast, that's a qualitative data. But if it is going at 40 meters per second, that's an exact quantity. So specific quantity. Okay, and quality would be like a trait, how it looks, smells, all right, tastes. Although you're not going to want to taste You have to make sure you don't taste anything in a laboratory. You don't want to get hurt unless it tells you to do so. Smells, taste, sounds like, feels like. You're really using your senses for all these things. Quantitative data generally will use tools to give you specific numbers, what the mass of something is, if it weighs 45 kilograms, or if it's moving at 30 meters per second, or there's 500 milliliters of liquid in a container. Okay. Once you record all your data, you're going to need to organize your data into data tables, so it's easy to see, read, and understand. And then you're going to use the data in those data tables to create graphs and other visual representations of the data and the numbers and the qualitative and the quantitative data that you've recorded. Okay, and then at the very end, after you've done everything, you're going to analyze that data and state a conclusion. And your conclusion is going to be based on the data. And it's basically, you're going to indicate whether your data supports or refutes your hypothesis. Okay? So you're going to state a conclusion where your data is used to support or refute your hypothesis. This is the point in your experiment where you're going to restate your qualitative and quantitative data to support your conclusion. Okay? So this is the point in your experiment where you're going to use and restate your qualitative data and your quantitative data to either support or refute your hypothesis. Okay? And so that's how scientists solve problems. Okay, real quickly, just to restate what we learned today. Scientists solve problems. They identify problems and state them in the form of a question. Okay? Then they research the issue or the question, and they come up with a hypothesis, which is and some people call an educated guess or an answer to the problem. Then they come up with an experiment to test the hypothesis. Many times it may be a controlled experiment. We discussed some of the traits of that. We'll get more in depth of that in another lecture. They make observations during the experiment. And if you remember real quickly, I'm just going to write them down. Qualitative and quantitative data are key terms you're going to want to learn. Okay? So they take those observations and they organize them into data tables. And then they use those tables to create visual representations in the forms of graphs and other visual representations of the data, pie charts, whatever. And then they analyze the data, and they state a conclusion. And in that conclusion, they make reference back to their qualitative and quantitative data to support their conclusion. Okay. And that conclusion is either going to refute or it's going to support their hypothesis. Okay? All right, have a good night, and we'll see you soon.